So in this video, we're going to take a look at central angles again, but now we're going to look at inscribed angles that are done with a chord and a tangent. So it's still kind of an ascribed angle, but it looks a little bit funny. The angle's kind of coming outside of the circle here. So with a central angle, this is the same idea as we did before. If I have a central angle, and that's an angle coming from the center to, the sides with radii, then the angle and the arc are the exact same degree. And we had inscribed angles before, and that was when you had an angle that was coming to the edge, so it's going all the way across the circle. Well, now I have this angle that's coming, it's a chord, and then it's connecting to a tangent. And remember, a tangent is a line that comes up to the circle in just one spot. It doesn't actually enter the circle, it just kind of touches it there at a point of tangency. So now I have an angle created with a chord and a tangent. It has the exact same property as an inscribed angle. It's half the measure of the arc that's created, but the arc actually kind of dives into the angle. It goes right into the vertex there because the end of the angle, it doesn't actually touch the circle, right? It's that point of tangency. So it's from the point of tangency to the other side of the angle there, and it's half of that angle. Or half the arc. If I have the angle, I'd multiply by 2 to get to the arc. So it's really very similar to the inscribed angle because they're the exact same property. They just look, the angle looks a little different when we draw it. So let's go ahead and look at this one. So we have the circle below has center P, so you can see that here. Suppose that the measure of arc QR is 116 degrees and that segment or line, QS, is tangent to the circle at Q. Find the following. So it's telling us that it's a tangent so that we don't have to assume that, and Q is the point of tangency. Okay? So now we're going to find the measure of angle Q PR and the measure of RQS. So let's focus on part A here first. So is angle QPR a central angle or an angle formed by a chord and a tangent? So if I look at QPR, I can see that this is formed by a central angle that is central. That's not a chord and a tangent. That's quite literally 2 radii going to the center. So now, if I know that this arc is 116 degrees, and I want to find the angle that kind of created it, well, it's going to be the exact same because it's a central angle, right? So that one's pretty darn easy because central angles and their arcs have the same degree. So I already have the answer to part A. It's 116 degrees. So now if I look at RQS, so that's RQS, that's this green angle here that I just highlighted. So now I want to know, is angle RQS a central angle or an angle formed by a chord and a tangent? Well, we can see that here's a chord, and this green part is covering up part of the tangent there. So it's definitely a chord and a tangent. Okay, so remember that means that the angle formed by the chord and the tangent is half the arc that is created. Well, again, we already have the arc here. It's 116 degrees. So if I take that 116 and divide by 2, that'll bring me to this kind of funny inscribed angle, right? Which is 58 degrees. So now we're going to look at another example. We have in the circle below, we have EF as a diameter. So you can see that marked here. And then EH is a tangent to the circle. So I just went a little farther than E, but that's okay. I just did the whole thing. And suppose that the measure of arc EFG is 306 degrees. So here's all of our given information. And sometimes there's too much given information. On this one, I don't think it's too much. It'll actually be helpful for the whole problem. So we're going to look for the measure of angle GEH. So I'm highlighting that here in green just so we can see it. So we're looking for this measure. So first, we're going to use that chord tangent idea. Remember, the angle is half the arc. So that means that I need to know what this arc GE is, okay, so that I can divide it in half and find out my angle. So I don't necessarily know what that is, but I do know, if you notice, this red goes all the way around from kind of green to green, right? The only thing left out is the part of the arc that I need. So I can take the whole angle and I can subtract that red area here, the whole circle, the whole 360, and subtract that 306 degrees. And that'll be what's left over for this arc GE, right? And now I can take that arc and divide it by 2, because if I have the arc, I can divide by 2 to go to the angle. So the angle has to be 27 degrees. All right, let's go ahead and take a look at the next one. So we have the measure of angle FEG. So that's now highlighted. It's also in green. I just kind of switched it over so we could see it. So now we're looking for this angle here. So now I need this arc, this FG arc, right? So we're told that EF is a diameter. Remember, that's why we highlighted it in blue here. And remember, that means that it's half the circle, okay? So we already found this one, and I took this away. Remember, this was 54 degrees. So if we know that half the circle from E all the way over here to F is 180 degrees, and that this little part here that we actually don't want anymore is 54, well, if I subtract, that'll tell me what's left over for FG, which is the arc I do need. So that's 126 degrees. So the arc I do need is 126, and now I can divide by 2 because this is just a basic inscribed angle, right? This is just two chords coming to the side here. So I still divide by 2. They're very similar properties. They're just, the angles look a little bit different, but you still divide by 2. So this angle is 63 degrees. So that's using the properties of inscribed angles to find the missing angle measures. I hope that helped, and I will see you in the next video.